Up above here, we see the origin of blood cells. I kind of try to sum down. I'll start with hemopoietic stem cells, and of course go to different intermediates, precursor cells, and finally, of course, develop. And I took some shortcuts, but of course into the final types of white blood cells. Next, in the plasma, of course, plasma is 91.5% water. Of course, I'm not looking for the exact percentage. I'm not going to ask you what the percentage of water is in plasma, but you see how high it is. Of course, a lot of salts, mostly sodium and potassium, calcium, magnesium, and of course, acid. Negative ions in order, mostly chloride, so G, mostly sodium chloride or table salt. Bicarbonate, phosphates, and sulfates. Helps to regulate osmotic pressure by how much salt, and that's why somebody has too much salt in their diet and their kidneys don't get rid of it. They have a problem with high blood pressure. Remember, it will make the blood more hypertonic, so it will suck in water from surrounding tissues. And as the amount of water increases in your blood vessels, of course, it's going to increase pressure. Of course, you can regulate this because if you get rid of that salt, whether through your kidneys, dump in your urine, or in other tissues, of course, you can regulate that blood pressure. And also because of the H plus and bicarbonate, phosphates and such, you can also regulate the pH. There are three major blood proteins that we'll talk about. Protein makes up 7%. The big one being albumin, like egg white. 60% of that blood protein made by the liver in small little packages with a nice little assemblage of amino acids. That's why no matter whether you're going to make keratin, myosin, actin, okay, whatever you're going to make, a mother hen packages inside the egg for the baby chick albumin. These packages of different types of amino acids. And then the little baby chick will chop them apart and then use the ribosomes to reassemble them in whatever protein it needs at the time. And that's what your liver does for you. You eat something like a steak dinner, your digestive system chops apart those proteins in the meat, and you will absorb all those amino acids. They go to your liver. You will assemble them and store them up as albumin and dump them into the bloodstream. And also it's used to regulate osmotic pressure, depending on how many of these have. That's why you don't transport that many amino acids individually, because again, osmosis. Remember, osmosis is by the number of particles, not by the size of particles. So sodium ion is the same as an albumin protein. Globulin makes up just over a third of your blood proteins. Three types, alpha and beta, both produced by your liver. These are sort of like life preservers. These are carriers of hydrophobic substances. In other words, transfer lipids and also for fat-soluble vitamins. They will hold on to the lipid in the middle, and outside is a ring of hydrophilic substances, so they will carry the substance in the bloodstream to its target. The only one that's different is gamma globulin. This is from your lymphatic system. These are basically the antibodies we mentioned before. The last one, fibrinogen, only accounts for 4%, but this is your blood clotting factor, the last blood clot factor that makes the actual blood clot to plug up a leak. And this is the precursor form of this. The gen on the end basically means precursor. This is the inactive protein. Plasma nutrients, we have various sugars, nucleic acids, a few amino acids, and some other minor proteins we'll discuss later. Lipids. Now, you also have clusters. Some proteins have more hydrophobic amino acids on them than hydrophilic, and they'll tend to cluster together with other hydrophobic substances, making a mass of what we call lipoproteins. Surface layer will tend to be phospholipids, which are both, have hydrophilic and hydrophobic characteristics, have some cholesterol and some, again, proteins with mixtures of hydrophilic and hydrophobic. Deeper core will be the lipid portion, which will be the triglycerides, and these are taken in by cells by endocytosis. when you bring in nutrients from your food, they're assembled in these little clusters and they're called chylomicrons. Now, when they go to your liver, you will now reassemble these in different types of packages to be put in the bloodstream and delivered to the cells to feed them. The first one is called very low density lipoprotein, or VLDL. These are a lot higher in triglycerides, remember, a lot of fatty acids, and these are very rich in energy, remember, twice as much energy by weight as proteins or carbohydrates, and contains less cholesterol. Okay. Now we have low density lipoprotein, which is going to have a greater amount of cholesterol. These triglycerides are removed from the VLDL, leading a higher concentration of cholesterol, and this can be a problem. Now with cholesterol, excess cholesterol can be removed from the body through the bile, as we'll talk about later in digestion. The problem is all these commercials and everything saying about good cholesterol, bad cholesterol. All cholesterol is just cholesterol. There's no good cholesterol, no bad cholesterol, as far as the molecule goes. And you need a certain amount of cholesterol. Again, the whole thing comes down to homeostasis. Good cholesterol is when you have the right balance of the different types of packages. Now, this is actually most of your cholesterol is packaged in LDLs, although considered bad because these tend to sometimes get too high. Now, so-called bad cholesterol is when, of course, you get too much cholesterol, and even some people have too low a cholesterol. They don't meet their nutritional needs. That's actually malnutrition. If it gets too high, it can separate out and plaque out in your blood vessels and start to clog arteries, especially those around your heart. And, of course, that's a bad thing. VLDLs are considered a good type. LDL is a bad type, even though, again, you have to have them all. Now, HDL, high density lipoproteins, now these have a higher percentage of proteins and also lipids, in other words, fatty acids, okay, triglycerides, and very low amount of cholesterol. These are considered the best. Now, again, they all three have their own ranges, and you have to maintain homeostasis in these. Now, one way that you can maintain a good homeostasis between these, your liver packages what you need. So if you maintain a good diet and also exercise, so your muscles need a good supply of these, you will tend to maintain a good supply, or I should say delivery from the liver. So a good way to keep your cholesterol good, a good balance, is because of diet and exercise, a miracle cure. I hate those infomercials that say, like, oh, it depends on your diet and also the genetics, so like your Uncle Jake. Well, if your genetics depend on your Uncle Jake, your mother's got some explaining to do. Okay? I hate when they use bad science. Now, sometimes even though your genetics can be pretty bad, there are some cultures where some people naturally, they die in their early 40s, especially men. Grandpa died at 42 from a heart attack. Dad died at 41 from a heart attack. When you start getting about 38 years old, you better write your will. Some have a little enzyme in their DNA makeup called lipoprotein lipase, which will take the VLDLs, which is a good packaging, and actually change it to LDL to be an unhealthy packaging. So you can eat all the healthy food you want. You can exercise every day. But your own genetics are going to mess that up, and you're going to tend to die of a heart attack. Now, again, these days with modern pharmaceuticals, we can keep a patient alive a lot longer. But just doing it naturally, you're probably going to die young 40s, early 40s from a heart attack. You also make your own cholesterol. So sometimes you're just your worst own enemy. Again, you can sit there, and of course if you take it in, you get the raw material, but you actually have metabolism for making your own cholesterol. The thing is, and you can uptake cholesterol, and we said you can also get rid of it through your bile. Now the problem is, again, your metabolism. Some people are very good at taking in cholesterol, so they'll tend to have high cholesterol. Again, you can add up all three of these parts. They also look at the ratios between these to determine health. Some people are very bad at dumping it into the bile, getting rid of excess. So they tend to keep it, and it keeps on getting higher and higher in the body. It's a catch-22, because when you secrete cholesterol in your bile, you're also using it to absorb more cholesterol. So you dump a bunch out, but then you regain a bunch. Then you dump it out and you regain it. And so this isn't where you say, like with salt, okay, stop eating salt, come back in 3 weeks, we'll test you. This is, okay, switch your diet and exercise program, come back in 9 months and we'll test you. Because you're not going to go down overnight, over a week, over a month. Okay, this is going to take a long time to adjust. We also have non-protein nitrogenous compounds like amino acids, a few. Urea, which remembers from the burning up of amino acids, you take 2 amine groups, that ammonia off of amino acids, put them on a carbon dioxide, makes urea. Uric acids from the breakdown of nucleic acids, and creatine will break down into creatinine. Blood gases, we'll talk about more later on with respiratory, but of course you're carrying oxygen to the tissues to burn fuel. Carbon dioxide is one of those things, of course, waste particle made from burning the fuel. And even though we do not chemically use it, physically we use nitrogen, the major gas in the atmosphere, in order to push back atmospheric pressure that's always pushing down on us.